Now, if you remember, the quadratic formula is used to solve quadratic equations written in standard form. So right over here, this is standard form for a quadratic equation. It's ax squared plus bx plus c is equal to 0. And based on the coefficients, the terms and this constant right over here, we're able to use this to solve for x. Now the discriminant is this b squared minus 4ac part. And notice how the discriminant is just the thing inside of the square root for the quadratic equation. So if you notice the quadratic equation, it has the plus or minus square root of b squared minus 4ac. Well, the discriminant is just this b squared minus 4ac. It's just the stuff inside the square root for the quadratic equation. And the discriminant tells you what type of solutions you'll get from this quadratic equation. Let's look at some examples. So if your discriminant, so if this b squared minus 4ac is greater than 0, then you're going to have two real solutions. Now, let me show you an example of this. So right over here, I have this quadratic equation. Now, my a value is going to be equal to 1. My b value is going to be equal to 5. And my c value is going to be equal to 6, right? Remember, this is for just the regular form for the quadratic equation, the standard form. Now, b squared minus 4ac, in this case, we have, so if b squared, that's going to be 5 squared, minus 4 times a, which is 1, times c, which is 6. So this is just going to be 25 minus 24, which is equal to 1. Notice how 1 is greater than 0, right? In this case, our discriminant 1 is greater than 0, meaning that we're going to have two real solutions. All right, so actually, let me just do the calculation right now. So we know the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So right over here, I'm just going to do the quadratic formula for this equation right over here. So I'm going to have x equals negative b, so negative 5, plus or minus the square root of, remember, we said b squared minus 4ac. Remember, we said that was 1. So all of this inside the square root is equal to 1. Now, this is all over 2a, and we know a is equal to 1. So all of this is going to be divided by 2, right? Because 2 times 1 is 2. Now, let's simplify this. So we know the square root of 1 is just equal to 1. So we have negative 5 plus or minus 1 divided by 2. So we're going to have two solutions, right? Either we have negative 5 plus 1 divided by 2, or we have negative 5 minus 1 divided by 2, right? This is the plus or minus part, right? You either have this plus 1 or this minus 1. So if we have negative 5 plus 1 divided by 2, we're just going to get negative 2 as our answer. And if we have negative 5 minus 1 divided by 2, we're just going to have negative 3 as our answer. All right, so we saw how in a quadratic equation, right, if the discriminant is positive, then that means we're going to get two real solutions. And you can also think about this logically, right? If you have x equals negative b plus or minus the square root of, and then this is our discriminant right over here. If our discriminant is a positive number, then the two answers we're going to get is either x is equal to negative b plus the square root of that positive number divided by 2a, or we're going to have x is equal to negative b minus that positive number divided by 2a. But notice how either way, we still get a real answer, right? If the square root of a positive number is a real answer, and we can do all of this calculation, and we'll still end up with this right over here is a real answer, this right over here is a real answer. So we got two real answers, right? This is the exact same thing that happened with this example. The square root of a positive number, a number that's greater than 0, right? That's going to be a real number. So we're either going to get negative 5 plus that real number, or in this case, negative 5 minus that real number. And we got two real solutions for this, right? Now, if your discriminant is equal to 0, you're going to have only one solution. Okay, so in this case, I have x squared plus 4x plus 4. Now, so my a term is going to be equal to 1. My b term is equal to 4. And my c term is equal to 4. So b squared minus 4ac is going to be 4 squared minus 4 times a, which we know is 1, times c, which we know is 4. So we're just going to have 4 squared, which is 16, minus 4 times 4, which is 16. So 16 minus 16 is 0. So based on the discriminant, we can see that our quadratic equation has only one solution. And we can check our work using the quadratic formula. So once again, we're going to use this formula. So I'm not going to show it here, but hopefully you have it memorized. So this is going to be x is equal to negative b. So negative b is negative 4 plus or minus the square root of, and then we know that our discriminant, we said how our discriminant is equal to 0, right? So we're just going to put a 0 here, right? And then this is going to be all over 2a. So we know a is equal to 1. So 2 times 1 is just 2. So based on this, we know the square root of 0 is 0. So we're just going to have negative 4 plus or minus 0 divided by 2. And notice how, right, when our discriminant is equal to 0, we either get negative 4 plus 0 divided by 2, or so we either get x is equal to negative 4 plus 0 divided by 2, or we get x is equal to negative 4 minus 0 divided by 2. Notice how whether you add or you subtract 0, you get the same result, right? Negative 4 plus 0 divided by 2 is negative 2, and x is equal to negative 4 minus 0 divided by 2. This is also equal to negative 2. So notice how you end up with only one real answer, okay? So this is because the reason why when your discriminant is equal to 0, so when the stuff inside your square root is equal to 0, you only get one solution. The reason for that is because it doesn't matter. It doesn't matter if you add or you subtract 0, right? Plus or minus 0 does nothing to our equation, right? We saw how when we added 0 to our equation, or when we subtracted 0 to our equation using the quadratic formula, we still ended up with the same answer because adding 0 and subtracting 0 do the same thing, right? So we're only going to get one answer. Finally, if our discriminant is less than 0, aka it's a negative number, so if our discriminant is like negative 1, negative 2, etc., then we're going to have no real solutions. We're going to have something known as imaginary solutions. So in this case, let's take a look at an example. So in this case, my a term is 1, my b term is 3, and my c term is equal to 3 as well. So we're going to have b squared, so 3 squared minus 4 times a times c, right? Now, 3 squared is 9, minus 4 times 3, which is 12. So we're going to get a negative number. And based on this, right, based on my discriminant, I already know that I'm going to get no real solution. I'm going to get imaginary solutions. So let's check our work using the quadratic formula. So we're going to have x is equal to negative b, so negative 3, plus or minus the square root of, in this case, 3 squared, b squared, right, b squared minus 4ac, right, 4 times 1 times 3. And we said how all of this is equal to negative 3, right? So in the square root, I'm just going to write negative 3, right? Because remember, our discriminant is the thing that's inside the square root, right? It's this b squared minus 4ac that's inside the square root. And we said how it's equal to negative 3. So I'm going to just put the negative 3 inside the square root. And all of this is going to be divided by 2a. So 2 times 1 is 2. And notice how we have a square root of a negative number. Now, how can the square root of a negative number lead you to a real solution? So think about it like this, right? If you want a square root of, let's say, 4, well, you're looking for two numbers, right? The square root of 4 is 2, and 2 times 2 gives you 4, right? So when you're trying to take the square root of a number, you want kind of the same number multiplied by itself 2 times, and it's going to give you the number inside the square root, right? So you want a number, when it's multiplied 2 times, it gives you that number that's inside the square root. Now, let's say if you wanted to find the square root of a negative number, let's say negative 1. Well, the square root of negative 1 can't be equal to a negative number because when you multiply two negative numbers together, you get a positive number. So this positive number will always be different from the number inside the square root, right? We said how in order for a square root to kind of work, right, the two numbers multiplied together have to be equal to the thing inside the square root. But if the two numbers multiplied together lead you to a different answer than the thing that's inside the square root, then obviously this isn't the correct answer, right? And the square root of negative 1, it also can't be equal to 1 because 1 times 1 gives you 1. And once again, right, our number is not equal to the number inside the square root. And it turns out that there's no real solution for this quadratic equation, okay? Remember I showed y'all these 3 examples, and let's actually graph them out to see what's happening. So when our discriminant is greater than 0, we get 2 real solutions. So what does this look like on a graph? So I'm going to use the same example before. I had y is equal to x squared plus 5x plus 6. And notice how when the discriminant is greater than 1, right? We saw this was the example I did before, right? Where our discriminant was greater than 1. And notice how if you actually graph this out, you get 2 solutions, right? You have 2 real solutions, right? When you have a quadratic equation, the solutions are also known as zeros, because guess what? These solutions are found when our y value is equal to 0. So when our y value is equal to 0, we have 2 solutions, right? So the solutions to quadratic equations are sometimes also known as zeros of the graph because they lie at y is equal to 0, right? So when our quadratic equation, when our discriminant is greater than 1, we have 2 solutions. When our discriminant, so this is the example I'm using right over here, this one. When our discriminant is equal to 0, we only have 1 solution. And what that means on a graph is that we have this quadratic equation where our graph only touches the 0 at 1 point. So it only has 1 solution, or 1 0 on the graph, right? It only touches the graph. And it only touches y is equal to 0 at this 1 point, right? Finally, when our discriminant is less than 0, or when it's negative, well, we saw how this right over here is an example of that. And what that looks graphically is, imagine if we graph this out. So it's y is equal to x squared plus 3x plus 3. And notice how my graph right over here actually has no real solution, right? Because my graph does not touch any 0, right? My graph doesn't touch this y is equal to 0 line.